Dear students, today we are discussing about the p-value. Okay, p-value is actually probability of rejection, and I will show you the graphs of computation of p-values. Sometimes we will find the probability, and we will find the probabilities corresponding to the distribution of statistic. Suppose you are considering a distribution, standard normal distribution. Then you know that in the case of a standard normal distribution, you will have a curve like this, okay. In this curve you can see that for the standard normal curve, it is symmetric and bell shaped, and its center value will be mean mu, and the two extremes minus infinity and infinity, okay. Okay, so in such curves we will have some critical region, and I will plot that critical region. Let us paste here. Yeah, I think it is clear for you. Suppose consider this is the density function of standard normal distribution, that is f of z, okay, and you know that this is the center value, okay. I think this may be the mu or mean value, okay. Let us denote this as mean value. You know, in the case of mean normal distribution, mean and median and mode are equal, okay. And suppose you are considering the critical region, let it be this is the left hand point of the critical region, so let it be the yeah, let us consider these 2 points, okay. This can be denoted as this point can be denoted as set 0 point set suffix 0.025, okay, minus set 0.025, and let this point be set 0.025, okay. So you know that from the previous semester discussion, you know that what is the probability between minus set 0.025 less than z less than 0.025 equal to 0.95, or can be considered as 95% confidence interval. 95% confidence interval for the what is that Z value. Okay, the probability that Z lies between minus Z alpha by 2 0 minus Z alpha by 2 less than Z alpha by 2 equal to 0.95. So you know that in this region, this area is 0.025. Okay, and also you know that since this is symmetric, so this area will also be 0.025. and suppose you have calculated the Z value. Suppose you have calculated the Z value. What is actually Z? Z is actually x bar minus, so what is that, sample mean minus and then mu naught. Okay, m naught divided by standard deviation. Okay, this is the formula of Z. You can compute this formula. Okay, you can suppose you have you may have to check mu naught equal to 3. So put mu naught here, that is 3 here. You might have selected a sample of size n, and from that sample of size n you can let it be 1 comma x2 comma etc. So from that you can find the sample mean. Okay, sample mean, and you can substitute that sample mean in this formula, and also you can compute the sample standard deviation and substitute that value here. So you will get, what is that? Yeah, you will get the Z value. And suppose you are finding probability of Z greater than this, what is that, Z dash or Z dash. What is actually Z dash? Or you can calculate modulus of Z greater than Z dash. What is actually Z dash? Z dash is actually this can be considered as Z dash. This is a what is that? Probability that mod Z greater than Z is a random variable. Z is the random variable in the x-axis. So probability of mod Z greater than Z dash. So suppose this is the point we have. This is the point the observed. What is that? Z dash. Okay. Or calculated Z dash. This is a point. Yeah, the observed result value is mentioned here. Suppose this is the observed result value. Then what we have to do? Okay, you can find the what is actually probability of mod Z greater than Z dash. This is the area under the curve. That means you are finding the two probabilities and adding that. What are the probabilities? Z greater than Z dash, plus probability that z less than minus z less than z dash. Z less than minus z dash. Yeah, this is that probability. So what is the probability? But you know that probability is actually the area under the curve. So you can add these two areas. What are the areas? Yeah, this one, and this one. Okay, this area plus this left side area. So that will be the value corresponding to probability that mod z greater than z dash. Okay, but you know that what is the rejection region? This is the acceptance region. You know, this is the acceptance region. Okay, acceptance region. This is the acceptance region. Okay, so what will be the rejection region? Yeah, rejection region is outside the acceptance region. So what are the region corresponding to rejection region? What are the rejection region corresponding to rejection region? Yeah, this will be rejection region, and this also will be rejection region. Okay, you have decided the acceptance region and rejection region, and you have computed what you have computed probability of mod z greater than z dash. That is, there is actually these red regions. Okay, and thereafter, suppose this is found to be, you know, sorry, this 1 minute. Actually, since z alpha by 2, it is because there is a gap in between here. So let us put the fill the gap with white color. So the area of this red region will be yeah, this right side red region will be probability of z greater than z dash, and left side red region will be probability that z. So let us write that point. So this point is actually what is that? Minus z dash. Okay, and this point will be this point means this point will be z dash. Z dash. Okay. So 2 point minus Z dash and plus Z dash. This point and this point. So in between minus Z and Z 0.02 there is a gap, and also in between this Z 0.025 and Z dash there is a gap, but at the same time what is the area, what is the area under the curve corresponding to red region? What is the area under the curve corresponding to red region? That may be the maximum area is the area left to the region set 0.025 is 0.025. So this area will be smaller than 0.025. So let it be 0.02. Okay. And again, yes, this one. This red region, area of this red region may be 0.02, and since it is symmetric, the area of this red region will be also equal to 0.02. So what is the total value? That is equal to 0.04. Right? Clear? This is exactly equal to 0.05. Right? So now we compute the area of blue region. Okay. What is the area of blue region? Probability of Z greater than Z 0.025 plus probability of Z less than minus, what is that value? Z less than minus Z underscore 0.025. What will be the value? That will be equal to, so what is this probability? This probability will be the value of the blue region. So let us make this region also blue. Okay. So what is the probability? Yeah, that is probability is nothing but 0.025. Again, plus probability of Z less than minus Z 0.025. That is the area of this region. So what will be that probabilities? Yeah, first one is right side probability is 0.025 plus second one is 0.025. Right. So this is the probabilities we have added together. Okay. So this is the so we obtained two probabilities. I will go back and you can see again. I think up to this you might have obtained the idea. Okay. So we have identified 2 points, minus z dash and plus z dash, and we have to compute probability of mod z greater than z dash, that equal to probability of z greater than z dash plus probability of z less than minus z dash. That is actually using some statistical tables you can find out this values as, it is only assumed values, 0.02 plus 0.02, that is summed together. So probability of that red region will be 0.04. Again we look at the points. What are the points? Minus z 0.025 and plus z 0.025. In that case we can add these probabilities. Exactly what is these probabilities? Yeah, this will be area of this right region plus area of this left region. Okay, so what is the area of this left region plus right region? That is 0.025 plus 0.025. That is nothing but 0.05. It should be 0.05 because we are considering 95% statistical significance threshold. So this is 0.025. But what is the area of this? Let us put another color. What is the area of this yellow region? What is the area of yellow region? That is actually probability of minus z 0.025 less than z less than z 0.025. Okay, what is that area? That is exactly equal to 0.95. Okay, that is actually 0.95. Okay, so this is the, so the remaining region would have the area 0.05 because yellow region has the area 9.95, so the remaining area would be 0.05. So the total area would be 1. Okay, I think you got the idea of construction of these areas. Okay, now what is p-value? This is p-value. This is p-value. Okay, this is actually p-value. What is p-value? 0.025. That is, what is the step behind computation of p-value? First of all, we have to find out z dash. Then we have to find out probability of rejection. That means probability of z greater than z dash. And then we have to find out what is the probabilities. Okay, you have to find out the numerical value like 0.04 in our example. But what is the speciality of this problem? This is the p-value. 0.025 is called the p-value. That means probability of mod z greater than that tabulated test value, test statistic value. But actually you know that the rejection region corresponding to the region which is left to minus z alpha by 2 and region right to the region z alpha by 2. If the area is 0.05, then you may have to identify the point as So I will show one more example. I will show one more example. So I think you got the idea of computation of p-value. This is the p-value. This is the value corresponding to what is that? Probability of rejection. This is the probability of rejection region. Probability of rejection region 0.05, because this right side is rejection region. This, this is rejection region. And in the left side also we have rejection region. Probability of, this is actually probability of rejection region. Okay, probability of, this is exactly equal to probability of probability of rejection region. Okay, this is p-value. Okay, this is p-value, this is the probability of rejection region. And how can we take the conclusion? You know that if the statistic value comes in rejection region, then we have to reject the null hypothesis. Okay, in this case we know that the statistics value is z dash. Okay, where is z dash situated? Yeah, z dash is the point. This is the point z dash. Okay, this is the point z dash. So if z dash is in the rejection region, then the probability of mod z greater than z dash would be less than 0.05. Correct? If z dash is in the rejection region, if it comes in any of the part of this region, then probability of mod z greater than z dash would be less than 0.05. In this case it is obtained as 0.04. Okay, so what type of inference we can draw from this? This problem, I will show you. Okay, this is the p-value actually. Okay, you can see this is the let's take another figure that will be useful for understanding the concept. Yeah, I think this is, yeah, it is not clearly mentioned. For this example we can consider take this picture. Okay, yeah, this is the look at this figure. This is a value corresponding to 330.6. Okay, and corresponding p-value. P-value means, what is the p-value here? P-value is probability of suppose this is z greater than 330.6 mod, let us take mod. Okay, what will be that value? So in this problem it is not mod, probably that z greater than okay, just we consider just the z less than
എന്നൊരു പറഞ്ഞില്ലേ എന്ന് പറയുന്നത് നവംബർ 2020 പരീക്ഷയ്ക്ക് മാത്രമാണ് അടുത്തതിനൊക്കെ അവര് മാറ്റാനുള്ളത്. നമ്മൾ 12 വെച്ചിട്ട് ഇനി അടുത്ത പ്രാവശ്യം നമ്മൾ ഇടരുള്ളൂ. ഞാൻ ഇത് വായിച്ചു
മനസ്സിലായി. 195. Okay. So in this case, what are the probabilities? Yeah, that equal to 0.01556 plus 0.01556. Okay. That is the p-value. Let us consider another example. Yeah, this is also required. Let us consider this. There are plenty of okay. I think I will make it bigger by, is it visible? Okay, anyway, this is not visible. Let me search for another visible pictures. I think this will help us. At the same time, the size is so small. Let us try. Yeah, it is very bigger. Okay, look at this figure. Suppose the p-value obtained is, now what is the p-value corresponding to this region? P-value will be, okay, let us color this region also. Anyway, leave it. What is the p-value? Probability of z greater than 2.58, okay, plus probability of z less than 2.58. Suppose you have obtained z dash equal to 2.58. You know the step involved in computation of z dash, that is nothing but x bar minus mu naught by standard deviation. So you can compute z dash, that is possible. So that we have identified it as 2.58. So in it, look at this region. After 2.58, the area of the area under the curve will be 0.01. So you know that probability is the area under the curve. So that is the area 0.01 plus 0.01 in the left side. Okay, in the left side you have 0.01 area, the right side you have 0.01 area. So what is the result? 0.02. Okay, so that is the p-value. Now suppose you are restricting 95% confidence interval or 95% confidence interval for the parameter, or suppose you are taking alpha equal to 0.05, that means significance level. Okay, alpha equal to 0.05, then alpha by 2 will be, what is the value of alpha by 2? Alpha by 2 equal to 0.025. Okay, suppose you are taking alpha equal to 0.1, then what will be alpha by 2? Equal to 0.05. Suppose you are taking alpha equal to 0.2, then alpha by 2 will be 0.1. Okay, so in the case of alpha equal to 0.1, that means alpha by 2 equal to 0.025. You can see that this is that point, this is that point. So the area of this region is, what is that? 0.05. So in that case, from the standard normal table, you can identify that this point will be 1.96. That means corresponding to area, we can find the value of the statistical value. Okay, corresponding to the area, you can find the statistical value. For finding that statistical value, you can search for what is that statistical tables. Okay, look at this table. Can you see this? Is it visible? When we look at this table, yeah, let us look at this table. Okay, let us look at this table. You know, this is for chi-square distribution. Normal. It is standard normal table. Suppose yeah, this is 0.05 percentage table. I will take and Okay, look at this table. You can see that this is corresponding to 0.05. Okay, 0.05. If this area is 0.05, if this region is 0.05, then this remaining green region will have area. Suppose this is 0.05, then blue region will have the area 0.25. Then what will be the area of this blue region? Blue region will have area. Subtract 0.25 from 0.5, so that the area will be 0.5, because half the region is considered, minus 0.025, that equal to 0.475. Okay, 475. So how can we find out the Z value corresponding to 0.025? That is the methodology we are discussing. Corresponding to 0.025, we can find out the Z value. For that, we are considering this blue region. Okay, blue region, and then identify the value 0.475. Where is 0.475 is situated? Look at these numbers. Yeah, it is given here. Okay, this is the value corresponding to, this is the value 0.475. So corresponding to 475, you can find out a value here, 1.9, and also you can find out a value corresponding to that column, 0.06. Okay, add that two values. What are the possible values? 1.9 plus 0.06. When we add these values, we will get 1.96. So that is the value of Z dash. Okay, you got the technique of finding the value of Z dash. First of all, suppose you want this is the value of let me write again, 1.96 plus 0.06, not 1.96, 1.9 plus, that equal to 1.96. That is the value corresponding to Z 0.025. Okay, not Z dash, sorry for that. The value corresponding to Z 0.025 is 1.96. Okay, so this is the methodology for finding the Z 0.025. Okay, now you can look at in a reverse manner. Suppose you are given Z value. Suppose you are given Z value, or Z dash value. Z dash value you are given, because it is a calculated value. Suppose you are given it is a Z dash value, and suppose it is 1.25, sorry 2.5h. Suppose you have calculated the value of Z dash as 2.58. So where will be the value associated with 2.58? You can look at this figure, and somewhere here will be the value of 2.56 will be here, 2.56. 2.58. Okay, after 2 and before 3, 2.58 will be somewhere here. Okay, this may be the value corresponding to 2.58. Okay, so find out the area in between 2.58 and infinity. Okay, so what will be that area? That area will be this green region. So that area may be some, yeah, that area is given in the previous slide. That area is 0.01. green region area, that is 0.01. So what is the inference we can draw? If probability of that area, that means probability of mod z greater than z dash is equal to 0.01, that is equivalent to say that corresponding to calculated z, corresponding calculated z dash lies in the rejection region. On the other hand, suppose z dash is found to be 1.9. Z dash equal to 1.9. So what will be the inference? So if it is 1.9, or suppose it is let us take 1.2. Suppose z dash equal to 1.2. Where is 1.2 situated? 1.2 may be somewhere here. Okay, 1.2 may be somewhere here. Okay, 1.2. That means area after 1.2 will be, what is the area after 1.2? You can calculate area after 1.2. That will be area of the new shaded region. This plus this. So what will be that area? That area will be greater than 0.25. So that may be some 0.03, maybe 0.03. So if we identify that the z dash value, then since this value corresponds to the area 0.03, and also you can see that 0.03 is much larger than 0.025. At the same time, you can see that corresponding to 0.03, 1.2 comes in the acceptance region. So we should accept the hypothesis. What is the reason? The value z dash value that equal to 1.2 lies in the acceptance region. Okay, you know that what is the acceptance region? In this case, what is the acceptance region? From this part to this part, it will be acceptance region. Okay, so 1.2 indicates that it lies in the acceptance region, so we should accept the null hypothesis. At the same time, in the earlier case, 2.58 indicates that it lies in the rejection region, so we reject the null hypothesis. So instead of comparing these z dash values, we can compare the areas. If this area, this is the calculated area, this is the calculated area. Since this calculated area is much less than this table area, we can say that the corresponding point will be in the rejection region. Okay, since this area is much less than this area, we can say that corresponding point will be in the rejection region, that is 2.58. In the second case, you know that this 0.03 is greater than 0.025. So in that case, we can say that the point 1.2 will be before this 1.96 value, table value. This set is 1.96. Value of this set will be 1.96 equal to 1.96. That's the table value. We have obtained that. Yeah, it is given here. Set 1.96. Okay. So set is 1.96. So that is the idea. Since 0.03 is much greater than 0.025, that is equivalent to say that corresponding z dash value is left to the table value 1.96. That means 1.2 lies in the acceptance region. So we can say that since 0.03 is much greater than 0.025, we have to accept the hypothesis. That means if p value, that is the computed value, is greater than 0.025 in this case. In other case, we will have 0.5 or 0.1, etc. In this case, if p value is greater than 0.025, that means z dash value will be less than 1.96. That implies z dash lies in acceptance region, right? Okay. On the other hand, if p value is less than 0.025, what we can say? Then in that case, z dash will be after 1.96. It indicates that z dash lies in rejection region. So we have to reject the null hypothesis. So this is the idea of p value and corresponding hypothesis testing inference. Okay, so we have to reject the null hypothesis. So there are two cases. If p value is greater than 0.025, that is equivalent to z dash value is less than 1.96. That means z dash lies in the acceptance region, so we have to accept the null hypothesis. On the other hand, if p value is less than 0.025, z dash lies in after 1.96, that is z dash lies in the rejection region, so we have to reject the null hypothesis. Okay, I think you got the idea of p value. This is the methodology for finding p value. Okay. You got the idea? We have used several tables, several graphs, several interpretations. And you try to understand this concept, and if you have any doubt you can ask to me, no problem. We will consider this idea throughout our analysis, and you should remember that this p-value concept is used in every statistical analysis, and this is the only criteria for accepting or rejecting certain hypothesis. So you have to get some good understanding about the p-values. I think there is no book for p-values itself, but you can study the p-value concept from Google or from this discussion or from statistical tables, etc. So I think you got the idea. Okay. I will give you one. Look at this video. This is the idea behind the p-value concept is available in this video. What happens? The empty space becomes lesser and lesser. Okay. So what is the empty space in this glass? Only the smaller portion. So other part is with water. Okay. So that is the idea of p-value. I think it is sufficient for today's session. Thank you. We try to understand and get the idea of the p-value we have to use.